Alright, so question 1, you're supposed to correct one question on your exam. I chose question 7. We were given this vector, and we had to describe all the conditions under which the vectors will be linearly independent. On the exam, I said that a, b, and c can only be real numbers, and that d cannot equal 3. But in order for the vectors to be linearly independent, there needs to be a pivot in each row. This means that a needs to be a real non-zero number, and that b plus c cannot equal 0, and that d cannot equal 3. Question 2, we need to answer this question. We need to see if this vector is in range of t. In order to see if the vector will be in range of t, there will need to be a solution to this matrix equation right here. And we will find a solution for x by augmenting the matrix and then row reducing it. And since the matrix is not consistent, this means that the vector is not in range of t, because at that bottom row we have 0 equals 1, and that's not true. Okay, so for number 3, we need to prove that 1 over 2p plus 1 over 2q is a solution to the matrix system ax equals b. So if we plug in 1 over 2p plus 1 over 2q, and we use the property of linear transformations, we get these steps. So here I'm plugging it in. After that, you can use the property t of u plus v equals tu plus tv, and then you get this. After that, we can pull out the 1/2 with the distributive property. So you get 1/2 of AP plus 1/2 of AQ. And you get, after that, you get 1 over 2b plus 1 over 2b, and that equals b. And since we got b, we know that 1 over 2p plus 1 over 2q is a solution to the equation. And we could do the same thing in part b. So we know that 1 over 3p plus 2 over 3q, using the same steps we did in part A, we also get b. That means that it's a solution as well. But with just p and q, we get 2b. So that's not a solution because we didn't get b. So that means p plus q can't work, and that not all linear combinations of p and q work. So basically that means that the weights on p and q just need to add up to 1, and then it'll work. So yeah, now that you have two solutions to the equation ax equals b, you can create infinitely many. We just need the weights to add up to 1, and there are infinitely many ways to get the coefficient 1, so there are infinitely many solutions. And that's it. Thank you.